In this video, we talk about implicit function and its differentiation. What's an implicit function? All the questions which we have done so far under differentiation were looking like y is equal to f of x. Y always written as a function of x. For example, y is equal to tan x, and or y is equal to x cubed plus 7x plus 8, y as a function of x. But an implicit function means it's a function in which the dependent variable is y, because y is always depending on the value which x takes. Y is a function of x. So y is called the dependent variable. If the dependent variable is not written explicitly in terms of the independent variable which is x. So if y is not explicitly written in terms of x, it's called implicit. So y is equal to sin x when I say y, the dependent variable, is explicitly written in terms of x. But if it is not done that way, then it's called implicit. For example, if I have an equation connecting x and y, like I say x square plus y square is equal to 7xy. So that's an equation connecting x and y. X is x and y, and not y is not written as a function of x explicitly. Then it's called an implicit function. So we're going to look at the differentiation of such functions. As an example, if you look at this question 67, it says x square plus y square is equal to 3xy plus 5. X square plus y square is 3xy plus 5. So your dependent variable is y, and it's not written like y is equal to f of x. So that's an implicit function because y is not explicitly written in terms of x. When you try to differentiate this kind of a function, we need to know another thing. I'm going to show one or two examples. Suppose I have a function like y square, and I need to differentiate this y square. First thing is, y square is like f of x the whole square, because y stands for f of x, So y square is like f of x the whole square. And how do I differentiate f of x the whole square? That's where we apply chain rule. F of x the whole square is 2 times f of x into f dash of x. So that's the derivative of y square. So y square will be 2 times f of x, 2 times y. Y square becomes 2 times y into y dash. Like f of x the whole square is 2 times f of x into f dash. So y square is 2 times y, 2 times f of x into f dash of x, the inside function derivative y dash. Y dash is same as dy by dx, or I could write it like 2y into dy by dx. So y square derivative is 2 times y into dy by dx. So if your function is in terms of y, the inner derivative is dy by dx will be appearing with the derivative. For example, sin y, what is its derivative going to be? It's like sine of f of x will be cos of f of x into f dash of x. So sin y is cos y into y dash, but often we write y dash as dy by dx. So it is cos y into dy by dx. Another example, e raised to y. How would I differentiate it? E raised to y derivative is e raised to y itself. E raised to f of x will be e raised to f of x itself into f dash of x. So e raised to y derivative is e raised to y itself into dy by dx. So one more time, your y square, if I try to differentiate, becomes 2y into dy by dx. Sin y derivative will be cos y into dy by dx. E raised to y derivative will be e raised to y itself into dy by dx. So anything in y square, when I differentiate, it's going to be like direct derivative, you write, times by dy by dx. For example, tan y will be sec square y into dy by dx. Log y would be 1 by y into dy by dx. Okay, so y cubed, another example, will be 3y square into dy by dx. So I'm going to restart with this question now with this knowledge of a function of a function or chain rule in it. So look at this question. First thing is we should identify this as implicit. Now why is it implicit? Because this is an equation connecting x and y, and y is not explicitly written in terms of x. It's not solved for y. It's not written as y is equal to f of x. It's an equation which involves both x and y in it. So it is implicit. So if it is implicit, what I do is I say differentiating this with respect to x. So term by term I'll differentiate with respect to x. So what you need to notice is that x square is direct 2x, y square will be 2y into dy by dx, but the right hand side when you go there, you should realize that 3x is one function times by y. So that's product between 3x and y. And that's a constant term 5 there. So let's start differentiating. X square derivative is 2x and that's it. But when you differentiate y square, it's 2y into dy by dx. So anything in y when you differentiate, it's followed by dy by dx. So y square becomes 2y into dy by dx. If it was y cubed, it would have been 3y square into dy by dx. If this was sin y, it would have been cos y into dy by dx. If it was e raised to y, I would have said e raised to y itself into dy by dx. So y square became 2y into dy by dx. But the right hand side is product rule, 3x into y. So that's product rule is u into v dash plus v into u dash. So I'm going to follow that rule. U 3x into v dash, first function into 3x into v dash, derivative of the second, derivative of y is dy by dx, plus v, second function, which is y into u dash, derivative of the first, derivative of 3x is 3, plus 5 will become 0 there. Now what you do is you can see that there are two dy by dx terms. So you bring them all to the same side and solve for dy by dx. So I'm going to mark these two dy by dx terms and I'm going to collect them on the left side. So I'll get dy by dx common factor. You have 2y here, and when I bring this term to the left side, minus 3x, because dy by dx is common factor taken out. And the term on the right side is 3y, which I'll copy first, 3y, and take this 2x to the other side, which is minus 2x. So I can rearrange it for dy by dx. So dy by dx is equal to 3y minus 2x divided by 2y minus 3x. So just solve for dy by dx, shift this term to the right side, and that's my dy by dx. So what you would notice is that if your question is in terms of x and y, your answer also turns out to be in terms of x and y. So that's implicit. So implicit function mostly gives you your answer in terms of x and y. So this is the question for you to try. You should pause the video and try to do it. When you differentiate this, you should realize that this r is a constant. So that's going to be derivatives will be 0. So for example, when first of all, is it implicit? How do we identify? Yes, it is not written as y is equal to f of x. This is an equation which involves both x and y is not explicitly written in terms of x. Of course, I can find out y if I need, but it falls under the category implicit function. So when I differentiate, x square will be 2x, y square will be 2y into dy by dx is equal to 0, and then you solve for dy by dx. That's something which you need to try on your own. Here we have another question, y plus sine y is equal to cos x, and it's clearly an implicit function because y is not explicitly written in terms of x. I don't know what y is equal to. It's an equation connecting both x and y, so this is implicit. So I say differentiating with respect to x, y becomes dy by dx, and then plus sine y derivative would be cos y into dy by dx. So anything in y will be followed by dy by dx. So like sine of f of x is cos of f of x into f dash of x. So sine y would be cos y into dy by dx is equal to right hand side is cos x, and the derivative of cos x is minus sin x. So I have got two terms with dy by dx, so I will take dy by dx common factor out into 1 here and plus cos y, is equal to minus sine x. And then I solve for dy by dx. So what is dy by dx then? Dy by dx is minus sine x divided by 1 plus cos y. So here is a question for you. 2x plus 3y is equal to sine y, and you can see that it is implicit. Question 71. X log y plus y log x is equal to 5. So this is implicit because x and y are mixed up in this equation. Y is not explicitly written in terms of x. So this is implicit, we know. So we are going to differentiate with respect to x, and that's when I realize that x into log y is product rule plus y into log x is also a product rule. So there will be product rule coming up 2 times on the left hand side. Product rule is u into v dash, first function into derivative of the second, u into v dash plus v into u dash, second function into derivative of the first. So x log y, when you say x is the first function and log y is the second function. So I'm going to apply product rule, first function into x into derivative of the second. Derivative of log y is 1 by y into dy by dx. So first function ux into v dash, derivative of log y is 1 by y into dy by dx, plus second function into log y into derivative of the first, derivative of u is 1, x becomes 1. So that's first function. One more time, first function x into derivative of the second, derivative of log y is 1 by y into dy by dx, because anything in y when you differentiate is followed by dy by dx, plus second function v log y into u dash, derivative of the first, which is 1, plus again it is product rule, so we follow the same rule again. Y into log x is product, so first function y into derivative of the second is 1 by x, plus second function log x, the derivative of the first is dy by dx. So u into v dash plus v into u dash is equal to, right hand side will be 0. And you can see that dy by dx, there are 2 terms. So I'm going to collect those 2 terms with dy by dx common out. You have balance x by y here and plus log x there. And these 2 terms will be shifted to the other side. Both will be negative. So I'll write negative log y minus y by x. Minus is common, so you can keep the minus sign out and say log y plus y by x. Both the terms are negative. Therefore, dy by dx will be, this whole thing will go to the other side and divide. So I get dy by dx is equal to minus of log y plus y by x upon x by y plus log x, which is your answer. So this is for you. X square plus y square is equal to 6y is equal to 0. This is implicit, and when you differentiate, x square will be direct, y square will be 2y into dy by dx, but this is product rule, 6x into y. Should pause the video and do that question before you go on to the next one. 75. This is xy plus y square is equal to tan x plus y. It is implicit because x and y are mixed up. So I have a product rule coming here at x with the first term, which is x into y, that's product rule. So first function into derivative of the second, u into v dash plus v into u dash, first function into derivative of the second plus second function into derivative of the first. That's what I'm going to do there. The rest of the questions are straightforward. So x into first function into derivative of the second, dy by dx, plus second function y into derivative of the first is 1, plus y square derivative is 2y into dy by dx. Anything in y when you differentiate is followed by dy by dx. So y square derivative is 2y times dy by dx is equal to, right hand side tan x will be sec square x plus y, and y is dy by dx when I differentiate. Now you can see that dy by dx is in 3 places. So collect all the dy by dx terms together. So dy by dx into balance is x here plus 2y here, and since I brought dy by dx to the left side, it is minus 1 minus dy by dx. I took dy by dx out, so minus 1 is equal to, you have sec square x on the right side, and this plus y, I put it on the other side as minus y. Therefore, dy by dx will be, I will divide it. So dy by dx is equal to sec square x minus y upon x plus 2y minus 1. So that's a question for you. Sin square x plus cos square y is equal to 1. It's implicit because y is not explicitly written in terms of x. So it is implicit. Another one. X cubed plus x square y plus xy squared plus y cubed is equal to 81. It's clearly implicit because y is not explicitly written in terms of x. It's x and y mixed up here. So we say differentiating with respect to x cubed derivative is 3x square. But when you differentiate x square y, that's product rule. X square is the first function, y is the second function. So first function into x square into derivative of the second, derivative of y is dy by dx, plus second function y into derivative of the first is 2x. So one more time, first function x square into derivative of the second is dy by dx, plus second function y into derivative of the first is x square becomes 2x, plus again product rule, x into y square. So between x and y square, x is the first function, so I say first function x into derivative of the second, derivative of y square is 2y into dy by dx. Anything in y, when you differentiate, y square became 2y into dy by dx. That's first function into derivative of the second, plus second function into y squared into derivative of the first, derivative of x is 1, plus y cubed, derivative is 3y square into dy by dx. Y cubed is 3y square into dy by dx is equal to 81 is 0. Now I just have to collect the x dy by dx terms. One here, and one here. There are three of them. So I say dy by dx into the collecting the terms. I have x square here, I have 2xy here, and I have 3y square here. So dy by dx into those three terms there is equal to all the remaining terms will go to the other side, and each of them is negative. So I say minus of 3x square plus 2xy plus y square. All of them are negative. And so dy by dx will be, this whole thing will go to the right side and divide. So that's my dy by dx there. So look at this question. This is y is equal to root of x plus root of x plus root of x plus etc. So this is an expression which goes to infinity. So I'm going to read it from the right side to the left side now. Root of x plus root of x plus root of x plus root of x plus root of x to infinity, the value is y. What I will do here is, on the right side, I will write root of x plus the rest of it. If I group it like root of x, I copied the first one, plus what is the rest? Just try to read that bit separately. I wrote root of x plus what is the rest of it? Root of x plus root of x plus root of x plus root of x plus root of x to infinity. And when I say root of x plus root of x plus root of x plus root of x to infinity, what is its value? Its value is y. So can't I say that this whole thing which I am supposed to write inside this bracket is y? So if I replace it by y, it will look like root of x plus y. It's actually an infinite expression. So even if I have written just one term there, the rest is still y. So you get y is equal to root of x plus y. So look at that again one more time. Y is equal to root of x plus root of x plus root of x plus root of x to infinity. So what I did is I wrote root of x plus. Then I'm saying the rest of what I have to write there. What I have to write there is root of x plus root of x plus root of x plus root of x plus root of x to infinity. But what is it? That's your y. So I wrote root of x plus y. Now that makes it easier for us to solve this question. Now the question looks so much easier. Y is equal to root of x plus y. So I say squaring both sides. So y became y square. Right hand side square root will go away. So get y square is equal to x plus y. And then we differentiate with respect to x because it is implicit. So differentiating with respect to x, it's not y, it's differentiating with respect to x, y square becomes 2y into dy by dx is equal to x becomes 1 and y becomes dy by dx. Collect the dy by dx terms, so dy by dx into 2y, and I brought dy by dx to the left side, so it is minus dy by dx, and dy by dx is common, so 2y minus 1. So I collected the two dy by dx terms together on the left side is equal to 1. Therefore dy by dx is equal to 1 by 2x minus y. So here you have a question similar to that. Y is equal to root of cos x plus root of cos x plus root of cos x plus etc. to infinity. Think about it. When you try to do this, you will copy this first and then you will say y is equal to root of cos x plus. After that, the remaining expression, you don't write it, but just try to say what it is. It's root of cos x plus 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 root of cos x to infinity. But what is its value? That's nothing but y. So can't I rewrite the right hand side like root of cos x plus the rest of it is again y. So the question will look like y is equal to root of cos x plus y, like this. And then you say squaring both sides, and then it's an implicit function. You should be able to differentiate it. So please go through the questions one more time if you have any issues, and then write them down and practice it.